Welcome to qnawire.
Alright guys, we're doing problem 12 of chapter 9. So the diagram shown follows the highest energy occupied molecular orbitals of a neutral CX molecule, where X is the same row of the periodic table as C. Based on the number of electrons, can you determine the identity of X? Well, yes. So C is carbon, it has 4 valence electrons. If we put it in terms of molecular orbital diagram, we're only going to be focusing on the electrons in the p orbital. So that's going to have 2 valence electrons involved in this, and we have 5 in our molecular orbitals. So we have to have 3 in our other atoms' non-bonding orbitals. And the one that's going to have this is going to be nitrogen. You can also tell that the atom that we were going to use was going to be before oxygen because you can see that the pi bonding is lower energy than the sigma bonding. So and that order flips between before and after oxygen. Oxygen will have sigma at the bottom and pi on top, while nitrogen will have pi on the bottom and sigma on top. So now B, would the molecule be paramagnetic or diamagnetic? Remember, paramagnetic means you have unpaired electrons. Diamagnetic means there's no unpaired electrons. So since we have unpaired electrons in our sigma orbital, then that means we are paramagnetic. So C, consider the pi and molecular orbitals of a molecule. Would you expect them to have a greater atomic orbital contribution from carbon, have a greater atomic orbital contribution from X? In fact, before I do this, let me just write N is equal to X, and this is our CX molecule. Oh, or an equal mixture of the atomic orbitals from 2 atoms. So atom X is nitrogen, which is more electronegative than carbon. The atomic orbitals of the more electronegative nitrogen are slightly lower in energy than those of carbon. The lower energy bonding molecular orbitals will have a greater contribution from the lower energy nitrogen atomic orbitals. So this has to do with electronegativity. Since nitrogen is more electronegative than carbon, it's going to as the contribution, it'll have a greater atomic orbital contribution than carbon.